How will the sun die? Is climate engineering a good idea? And could we see city lights on an exoplanet? All this and more in this week's Question Show. Hi everyone, welcome to the Question Show. Your questions, my answers. Now, as always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather a bunch of them up and I will answer them here. Now, I record this show live every Monday at 5 p.m. Pacific time. So if you want to be part of the show, ask your questions live, you should come and join us. There'll be a notification to the next episode somewhere on my channel. You're also going to see code words pop up in the corners of the screen, and these are votes, a way for you to support what you thought were the best questions of this week. So when you are making a comment down in the comments below, just put in that code word, that Star Wars planet name at some part of your comment, and then we can count all those up, and I will give a shout out to whoever got the most votes next week. So go ahead, don't forget to vote. But before we get into this week's questions, I want to give an update on our book club. And this is your essentially just recommending books for me to read, and I'm going to tell you what I thought. And so this week, the book that I wanted to recommend is Termination Shock by Neal Stephenson. And I've been wanting to read this book for a while, and people have been asking me if I had read it, and I finally got around to reading it. And I mean, it's a Neal Stephenson book, and I like them all. 70s was fantastic. I think all the way back to Snow Crash. I really like Neal Stephenson's work, and this was terrific. The gist of the story is that an eccentric billionaire decides he's going to fix climate change single-handedly and sets up the biggest gun in the world and starts firing sulfur dioxide into the upper atmosphere of the Earth. And obviously this causes mismatched repercussions for various places around the Earth. Some people get more rain, other people get less rain, and it deals with the repercussions of one person attempting a geoengineering solution to solve a problem that faces all humanity. But it's told from many different characters, and it's sort of the future technology. And so it's like near future, but it's, Neal Stephenson invented the metaverse. And so he doesn't really cover that too much, but there's a lot of really cool technologies. And the coolest technology that I liked in this was that they use Mars landing sky cranes to deliver soldiers to the ground in a very fast way. So the soldiers jump out of an airplane flying at a really high altitude, plummet to the ground, and then the sky crane sort of delivers them right to the ground so they can go into operation immediately without like a big bulky parachute and all that. It's a really cool technology. Drones are everywhere. It was a pretty interesting idea of the future. So I highly recommend it. Termination Shock by Neal Stephenson. Now, if you have book recommendations for me, there'll be a link to the book club down in the show notes below. All right, let's get into the questions. Bentley and Grant videos. I know you did a video recently on the death of the sun, but I don't think you answered what happens to the sun in the black dwarf stage. Will there ever be a solid surface on the sun? So the black dwarf is the final stage of the death of a star like the sun. So we'll sort of rewind the cycle first to get back to a regular main sequence star like our own sun, of course. Star has layers. It's like an ogre. It's like an onion. At the very center of the star, you've got the core, which is where the pressure and the temperature are so high that fusion is going on. Hydrogen is being mashed into helium through a complex process. Energy is being released. That energy is pushing outward on the star that counteracts the inward force of gravity that's trying to pull the star inside on itself. And then outside of that, a place that's too cool and not high enough pressure for fusion to actually happen, you have what's called the radiative zone. And this is sort of like a shell that goes around the core of the star. And then outside of that, you've got what's called the convective zone. And this is where blobs of stellar material rise and fall. They reach the surface, they reach space, and they release energy, and then they fall down in columns down to the top of the radiative zone, pick up a whole bunch more energy, float back up to the top, and release that energy out into space. And when the sun reaches the end of its life, when it's used up all of the usable hydrogen in its core, it switches to helium burning. And so now it starts to convert helium into other elements, and then it runs out of that and runs into higher elements. And eventually it just can't support the pressure and the temperature in its core any longer, and it dies. But before it dies, it goes through this process where it sloughs off its outer layers, sort of bloats up as a red giant, sloughs off outer layers into space, compacts back down, heats up again, bloats up as a red giant, fires off more shells into space, and it performs this process several times until finally it's essentially given off all of the material that remains, and all that's left is the core. What was before the inside of the star, surrounded by all the stellar material, is now all that remains, and this is a white dwarf. And it is now no longer capable of performing fusion, but it's still incredibly hot. And now it just cools down. And in the case of our sun, it's going to be something like carbon. That is going to be the final outcome of all the different fusion processes that were going on inside the sun when it finally shut itself down. But it's going to be really hot carbon. And over the course of millions, billions, maybe even trillions of years, it will eventually cool down to the background temperature of the universe. And as this carbon cools down, it crystallizes like a diamond. In fact, that's what they call it. It's going to be the largest diamonds in the universe are going to be these cooled down cores of stars, of white dwarfs. And eventually you're just left with this diamond, space diamond, that is the background temperature of the universe. So will it have a solid surface? Yeah, it'll be a diamond. You could walk on it, except it has immense gravity and would squish you if you tried to walk on its surface. But theoretically, you could. It's sort of a bizarre future for the sun, and that's a black dwarf. But they take so long that even the first stars have yet to turn into a black dwarf in the age of the universe. We're still looking at billions, maybe even trillions of years before this happens. Mars Overland. What are your thoughts on climate engineering? Are there any studies showing negative consequences? Geoengineering is this idea that if we can't get our carbon emissions under control to the point that we're able to limit our greenhouse gases and the temperature continues to rise, we might need to use some other mechanism to cool down planet Earth to get the environment back into shape long enough for us to get our greenhouse emissions under control. There's been a lot of ideas, and they're very clever. Like, one idea is that you put a bunch of bubbles in space at the Earth-Sun L1 Lagrange point, which blocks some of the light from the sun enough that it cools the Earth back down. Another idea is that you put sulfur dioxide into the atmosphere, which blocks the light from the sun and cools the planet down. You dump enormous amounts of iron into the oceans, which then feed the bacteria, which consume carbon dioxide and then fall to the bottom of the ocean, and that gives you a solution as well. And the scary thing about these ideas is that many of them are actually feasible, like especially the sulfur dioxide one. To be able to put large amounts of sulfur dioxide into the atmosphere, you would need to design a new kind of airplane that can fly very, very high, but it doesn't break the laws of physics. We just don't need airplanes that do what this airplane would do. But I've heard that it would cost a few $1 billion a year to put sulfur dioxide into the atmosphere. You have to run thousands of flights of this airplane, constantly dumping sulfur dioxide. And it would work to some extent. But the problem is that you have unintended consequences. That we've seen this time and time again, that every time that we attempt to do something at a vast scale, we get unintended consequences. From releasing certain kinds of animals and then releasing other animals to eat those animals, and then other animals eat those animals, and no animal is eating the animal that it was supposed to. It's eating the animals that it's not supposed to. Every time we try to interfere at a large scale in our environment, we mess it up. And this is like back to the book club, Termination Shock, is that the effects of climate change are hitting different nations on Earth at different levels. Some places, like the Netherlands, are just a little higher than sea level and are going to suffer from rising water levels compared to places like Canada. Like here in Canada, we're probably going to do okay for a while as our temperatures rise. But I think that we don't know. And that's the problem. That's the scary thing. And with Termination trucks, someone's going to go, we're just going to do it. We're just going to take the risk that you're not putting in the sanctions on reducing your greenhouse gases. And so we're just going to do it. And that's what scares me, is just that we don't know what the unintended all we know is that there will be consequences, and they will be in ways that we weren't expecting. And that scares me. So I wish that we could cut our greenhouse gas emissions down to reach the temperature increases that have been proposed by the various, climate scientists. I don't think we will. And I think that people are going to take this into their own hands. So yes, there are studies that show negative consequences. There are studies that show positive consequences. And it's the kind of thing that you do. Like, is living in a lifeboat, like, are there negative consequences to living in a lifeboat? Abandoning your cruise ship to stay alive in a lifeboat? Absolutely. But if you can't be in the cruise ship anymore, then the lifeboat's the best that you can do. And fables. Hey, Fraser, can you please estimate in how many years we're able to see artificial illumination of an exoplanet in a photo in case there's a civilization? So I can't estimate. Well, I'll try it, but I want to sort of explain what you're getting at here, which is a really cool idea. So this idea of technosignatures, that we could be scanning the universe to search for the kinds of behaviors that humanity does at a larger scale from alien civilizations. And so when we look at the kinds of things that human beings do, we put out greenhouse gases into our atmosphere. We put out chlorofluorocarbons into our atmosphere. We have satellites orbiting planet Earth. We're sending out communications in various wavelengths. We are releasing energy of certain types, and we potentially could have nuclear wars and things like that. And so we eventually hope to be able to start mining asteroids, and that could have some sort of signal that is obvious. But the light coming from our cities is something that could be detectable. And that's because it's giving off a very specific kind of wavelength, right? The illumination that we have in our cities that is totally visible. Like if you're in orbit and you're flying over the Earth, then the city lights are the only thing that you can see on planet Earth. And the existence of humanity is super obvious. And so this is the kind of signal that people have proposed that we could search for in other worlds. You point a telescope at another star system, you block out the light from the star so that you can observe the planet, and then you watch how the light of the planet changes as it turns throughout its day. And it's going to have its daytime, and then it's going to have its nighttime, and you're going to be watching for subtle changes. Like when you think about Earth, when you think about the brightness of the night side of Earth, it's going to change when you're looking at the Pacific Ocean compared to when you're looking at the continents. When North America is passing or Europe is passing in front of you, planet Earth is going to be brighter. But as you can probably imagine, the changes in this brightness are extreme. I mean, you're already doing the Herculean job of blocking the light from the star so that you can reveal the planet. But then you are observing the planet long enough that you can actually see these changes in brightness. The shortcut way to do this would be to use, say, the Solar Gravitational Lens telescope. That's where you fly a spacecraft out to the point where the sun acts like a natural gravity lens to be able to focus the light from some target. And then we could see a megapixel image of an exoplanet using this method. And we could absolutely see city lights. So I think, based on what we want to be able to see in exoplanets, we're not going to be able to see the highest resolution stuff until we go to the Solar Gravitational Lens. And that's going to happen in one fell swoop. We will see 1 pixel, and then the Solar Gravitational Lens spacecraft will show up at its destination. And now we will see a megapixel. We will see 1 million pixels of a planet, thanks to the gravitational power of the sun acting as a lens. So when's that going to happen? Like, you wanted my estimate. And so I think that I think the solar gravitational lens is exciting, and more people are really getting behind this idea. The challenge is getting a spacecraft out to that distance. The Voyager spacecraft haven't even gotten that distance, and they've been traveling for like 50 years. And you want to go faster than that, you probably want to be able to do it in about 20 years. So my guess is that somebody is going to attempt to launch a solar gravitational lens telescope in about 10 years from now, say by early 2030s. And then it's going to take about 20 years to reach its destination, 2050. So my guess is that we will be able to detect the presence of an alien civilization through their illumination by around 2050 or so. Bravo 01. Could there be hidden habitable worlds with advanced societies within the realm of an event horizon of a black hole? Within the event horizon? Like inside the black hole? No. Well, maybe. It depends on the mass of the black hole. So when you have a black hole, a stellar mass black hole, say a black hole with 10 times the mass of the sun, then the event horizon of that black hole is actually very small, just a few kilometers across. And if you get within the event horizon of that black hole, the tidal forces are going to tear you apart. That's that spaghettification. And we don't know what goes on inside the event horizon of a black hole, but you can assume it's just more spaghettification. Worse, because now all of space-time is tangled up into knots, and your atoms live in space-time, and they're now getting tied up into knots. So that would be a bad day. But if it was like a really massive black hole, say like the supermassive black hole at the heart of the Milky Way, or maybe like one of the really big ones, like the ones that are billions of times the mass of the sun, then they can be as large as the solar system. You could fly. There's no tidal forces, or almost no tidal forces, and you could fly into one of those black holes and not even realize it, but you're on a one-way trip. And so could you survive? Like, could you go into orbit around the singularity? We don't know. We don't know what's going on inside the event horizon of a black hole. It might be that a black hole is just like 1 centimeter below the event horizon, and then that's all black hole inside. Or it might be that the singularity of the black hole really is an infinitely dense, infinitely small object at the center of the event horizon itself. So we just don't know. So I wouldn't want to live inside a black hole event horizon, but living beside an event horizon is absolutely feasible. So when you think about the movie Interstellar, where they had these planets that were orbiting around this supermassive black hole, Kip Thorne, one of the pioneers of gravitational wave astronomy, did the math and figured out what it would take to be able to have a planet that close to a supermassive black hole. As you feed material into the black hole, it releases energy, it releases heat that you could use. The downside, or maybe it's the upside, is that you're going to experience significant amounts of time dilation depending on how close you are to the black hole. And so you're going to experience a sped up universe because you're really close to the black hole. But this has been proposed. Like if you're nearing the end of the universe and all of the usable forms of energy have long gone, you could huddle up close to a black hole. And in fact, you would start to see a blue shifting of the cosmic microwave background radiation itself. It would go from microwave back into infrared and maybe even to visible light and higher. And so it would be like the whole sky was bright because you are seeing the blue shifted version of the cosmic microwave background radiation. And you could have used that for solar power until even that faded away. And the only way you could dilate your time faster would be to get closer to the black hole and fall into the event horizon. So it's a cool idea. And in fact, there's a great website where someone proposed like the largest possible civilization, where you would have like a really enormous supermassive black hole, and then you would surround that with other supermassive black holes. And then those supermassive black holes would be surrounded by more black holes. And then you would have planets orbiting around. And there's a way that you could make this whole thing be stable. And you could have millions of habitable planets orbiting in this system all together. Or maybe it was like a black hole in the middle and then stars. Anyway, you can sort of use black holes as gravitational anchors to build very complicated and very high population civilizations. And wouldn't it be cool, right? If you had a planetary system, which consists of 10,000 Earth-like planets orbiting around 100 stars, and everything is in perfect clockwork motion. Nothing is getting out of balance. And if you want to fly to another planet, it's a short hop. We could do it with our technology. It's a really cool idea. So I wouldn't want to live inside a black hole, but it would be interesting to live near one. If you like my answers to your questions, as well as the other things that we do at Universe Today, consider joining our Patreon club. You'll get ad-free experience on universetoday.com for life, even if you unsubscribe. You'll get ad-free videos, early access to interviews, as well as other perks that are exclusive to our Patreon community. Thanks to everyone who's already subscribed, and welcome to our recent newcomers: Thomas Eskridge, Melissa Holebach, Schlamm, Dave Mermelstein, Mike, Joanna Martin, Rakesh Chowdhury, John DiNardo, Brian Keating, Michael Prochata. Join the club at patreon.com/universetoday. Jim Smith, where do iron meteorites get formed? All of the asteroids that we see are piles of rubble. Good question. So when we think about meteorites, right, we think about the solar system. Like, it is the sun with 99% of the mass of the solar system, and it's mostly hydrogen and helium, but it's also polluted with heavy elements. There's several times the Earth's worth of rock and metal inside the sun. So there is metal mixed in with the solar system. But the question is, like, how do you get meteorites that are made out of metal compared to meteorites that are made out of rock? And here in the Earth, we have a clue, which is that the Earth has a rocky outer core, and then it has a metal inner core. And what happened was, a long time ago, the beginning of the solar system, the Earth was molten. And all of the heavier elements, the denser elements, the metals, sunk down into the planet and collected into the center of the planet. Like, there's tons and tons of gold and platinum on Earth. It's just down at the core of the planet. And this process happened. It happened on Mars. It happened on Europa. It happened on Venus. It's happened wherever you have a planet in hydrostatic equilibrium that is molten from its formation at the beginning of the solar system. And then over time, all this stuff concentrates inside. And so then again, like, how could we have an asteroid made of metal? And so that tells you that something had to destroy a planet, that there were planetoids in the past, and they wouldn't have to necessarily be as big as the Earth or Mars or whatever. They could be smaller than that would have gotten these distinct layers inside. And then they would have gotten smashed by some other asteroid and torn apart. And now what were metal surrounded by rock has now just been blasted out into space, into small fragments of rock. And asteroid Psyche is thought to be an example of this, a giant chunk of leftover planetesimal core that was destroyed by some impact with another asteroid. And NASA is building a spacecraft that's going to go and examine Psyche and try to be able to see it. And I always say, like, one of the coolest things that we might see on asteroid Psyche is that we might actually find it has volcanoes where it's blasting out molten metal volcanoes. And so when you have a metal meteorite, which I have several, you've got something that formed in the heart of a planetesimal planetoid, and was shattered and sprayed out into space. It's a really cool thought. It's about 15% of the meteorites are chunks of metal, or metal meteorites. And the other 85% are all of the rocky asteroids that were shattered and smashed and collected together. And yeah, I mean, like, if you could go to one of those rubble pile asteroids like Bennu or Ryugu and sort of dig through it, you would find metal meteorites in there that it had collected over time from the solar system and added to its mass. Edward Teach, in Planet Mars, they found a chemical called perchlorate. How did the chemical get there? Now, I don't know the exact chemistry of how you get perchlorate, but it is a reaction of the ultraviolet light from the sun hitting the upper layer of the Martian regolith and creating this stuff called perchlorate. And the perchlorate is poisonous. Like, if you took a bunch of Martian regolith and mixed it up and drank it, it would not be good for you. But you can wash it out. And so when the astronauts get to Mars, they want to try and grow their plants in the Martian regolith. All they have to do is wash this perchlorate off. And it might just be like just water will do the trick, or maybe you're going to need to do something to actually nullify the chlorine in it. But it is only in just the top few centimeters of the regolith on Mars, and it just comes from the interaction of the ultraviolet radiation over long periods of time. And it's one of the reasons why people think that the Viking lander life experiment was so inconclusive, because it's hard to believe that you could have bacteria living in that top layer of the regolith on Mars in such a toxic environment. And it shows you that if we really want to try and find life on Mars, we're going to have to dig deep. We're going to have to go down several meters, probably 10 meters, to really get a nice, clean sample, a place that is protected from space, to really figure out whether or not there's life currently on Mars and bring that home or examine it on Mars. Latter-day Saints. You, sir, are an excellent science communicator like Michelle Thaler, but I'm curious why the ocean surface is called sea level if water curves and doesn't find its true level. Well, I'm in very good company then. Michelle Thaler from NASA is a terrific science communicator. And I'm, based on your username, I'm sure you're asking a loaded question, but I'll bite. Planets like the Earth and Mars and, even stars, right? A star, all of these objects are in what's called hydrostatic equilibrium, which means that the gravity that is pulling inward on this object is strong enough to pull it into a sphere. And so if you went and you took the moon and you smashed it with some other object, it would turn into this spray of molten rock and debris. But then the mutual gravity of all of those particles would pull themselves back together, and eventually it would form a sphere again. And that's because the mutual gravity of all of the objects, the desire to pull towards the center of mass, is stronger than the tensile strength of the material itself. But if the object gets small enough, then like say Phobos, right, or an asteroid, then the amount of mutual gravity that's pulling it together isn't strong enough to put it into that level of hydrostatic equilibrium. But water, it has no tensile strength, or like maybe it does, but very little. Water wants to flow and wants to find this perfect equilibrium. And so if you had like a blob of water, it was only water out in space, it would form this sphere. Think about how you blow bubbles, right? You blow a bubble, it's going to pull itself into a sphere because of the surface tension and because it's trying to minimize the volume on the surface area of the bubble. If you have a blob of water out in space, it's going to form this perfect sphere. And then it's going to crust over and it's going to be like Europa. And so the Earth has the rock surrounding it, and then it has the water on top of it that is attempting to balance itself out as best it can across the surface of the Earth. Now, the moon, of course, is pulling with its gravity, and that can change the height of where the water is. But essentially, gravity wants to make everything a sphere. Black holes, neutron stars, white dwarfs, giant stars, small stars. If it can, it wants to sphere the universe. Nemyanja Ignatovic, your opinion about single stage to orbit. I'm against it. I think single stage to orbit is not an efficient idea. So when you think about a rocket, like think about even the recent launch of Artemis, you've got the solid rocket boosters that are attached to the side of the rocket, and you've got the core stage, and then you've got the upper stage, which contain the Orion. And the rocket launches, the solid rocket boosters burn through all of their fuel, and then they're ejected. And then the core stage burns through all of its fuel, and then it's ejected. And this idea of ejecting your fuel tanks is essentially the most efficient way that you could get to space. But the idea of a single stage to orbit is that you would carry your fuel tank all the way to space, even when it's empty, and you have to lug that fuel up to space. Then you could come back down to Earth, refuel, and then fly back off to space. And, it makes sense on paper because you're not having to throw away your rocket. You're not having to destroy all of this really expensive hardware that you create. But the amount of cargo that you can actually carry while still pulling your fuel tanks all the way to orbit as well is fairly low. And so the best idea that has been thought of so far is a fully reusable 2-stage rocket. And this was the original idea for the space shuttle. If you go back to the 1970s at the original plans for the space shuttle, it was going to be a fully reusable 2-stage rocket. When you think about the big orange fuel tank, that would have been a big space plane. And then, or I guess not quite a space plane, but it would have been the first stage. And then the top part would have been the orbiter would have sat on top of the flying fuel tank. And then this stack would have taken off. The fuel tank would have detached while the orbiter went up to orbit, and the fuel tank would have flown back down and landed at a landing pad, and then the top part would have flown back down and landed at the landing pad. And then for whatever reason, compromises, I don't know if the actual technology would have even worked, but it was pretty cool when you think about what the space shuttle could have been. Like the ideas that SpaceX is attempting right now, they were ideas already had back in the 1970s, even in the 60s. Like I always joke about this or think about this, that every great idea that people are attempting to do now, there is a technical paper from NASA written in the 1960s that describes this idea. Artificial magnetospheres, rotating space stations, and they were less constrained by our modern requirements. And so their imaginations run wild. Like there's nothing more interesting than browsing through NASA proposals from the 1960s. It's rich history. I highly recommend it that you do it. And so the fully reusable 2-stage rocket, a fully reusable 3-stage rocket might be an even better idea, even more efficient, but a 2-stage rocket is great. And that's what Starship is going to be. You're going to have the top part of the rocket and the bottom part of the rocket. Both will be reused. And you, just with that idea, as you launch up, and as you run out of fuel in the booster stage, you release the booster stage. And so now the rocket no longer has to carry the enormous weight of the booster stage. Instead, the booster stage goes and lands somewhere and gets refilled. And then the upper stage flies itself to orbit. And then it re-enters the atmosphere and gets itself refilled. And then they get stacked back up and then they go and do it again. And that's vastly more efficient than a single stage to orbit. So people have tried single stage to orbit for decades, and they've just never been able to make it work out. The closest of that was the X-33. NASA was attempting to create the next generation, which would be a single stage to orbit, look like a big fat space shuttle. And in the end, the weight constraints were just beyond what they could handle. They just couldn't keep spending money on this idea, and they had to cancel it. So no, I don't think single stage to orbit is ever going to take off, pardon the pun. It's going to be fully reusable 2-stage rockets like Starship. And in fact, the costs on Starship are so affordable that every other possible launch system, like a space elevator or an orbital loop or any of these ideas, they just pale in economy to a fully reusable 2-stage rocket. Maybe when we get a better fuel system, like if we get, say, metallic hydrogen, then we'll be able to have a single stage to orbit, and it'll be like we're living in the expanse. But until then, it's going to be Starship and versions of Starship from all the rocket companies for decades. Tom C, is China landing on the moon in 5 more launches? Well, I wouldn't say 5 more launches. China launches dozens of rockets every year. They've built a space station. They're sending new astronaut crew and cargo up to their space station. They launch weather satellites, military satellites. They're busy launching a lot of rockets. They've launched a mission to Mars, and they've launched now 5 missions to the moon, the Chang'e series. And they have already recently, in the last couple of days, the director of the Chinese Space Agency laid out their plans for Chang'e 6, 7, and 8. And the plan is that they're going to have humans return to the moon by the early 2030s to stay. So they're going to build a research facility on the moon. They're going to, and when you think about it, they have laid out all the groundwork. You've got the sample return mission, which was designed to prove that they can land a payload safely onto the surface of the moon. They can fire a return spacecraft off of the surface of the moon and have it return safely to Earth. That's testing the Apollo 11 process of landing on the moon and getting back to Earth. They've got a lot of other really interesting hardware and new rocket systems under development, heavy lift vehicles that they're planning to do. They have this very specific plan that we are getting more and more details about every year about how they're going to be returning to the moon. So will it be 5 more launches to the moon? That sounds about right. I would say within like Chang'e 10 or 11, if they don't give it a different name, will probably be a human mission to the moon. And then they will quickly start building a base and they will live there and have a research station on the surface of the moon in perpetuity, as long as it is a powerful demonstration of China's capability on the world stage. And that's why they're doing it, right? I mean, like when the Americans landed on the moon, their goal was to beat the Soviets to the moon and to demonstrate that they had better technology, a better economy, they were capable of great things. And it almost bankrupted the Soviet Union attempting to keep up with the Americans in doing that. And for China, being able to send humans into space and eventually to send people to the moon is to prove that they are also worthy of respect on the world stage. Now, I'm not going to say like I agree with that justification for why they're doing it. I'm just saying that's why they want to do it. But still, I mean, if the Chinese are able to build an entire rocket industry and get to the point that they're able to build and support a human space station on the moon, that's impressive. And I think, one of the common complaints that's leveled at China is, well, they stole a lot of the technology or they bought a lot of it from the Soviets and the Russians. It's true. They probably did. But if they're at the point where they've got a station on the moon that is continuously occupied and they're doing science up there, and they're the only nation that's doing it, like at a certain point, that argument starts to fall flat. Like nobody else has developed the technology to develop a permanent establishment on the moon and have it be continuing forward with more and more missions going on. So I look forward to seeing what happens. My wish always is that countries will work in collaboration, that the Chinese form a partnership with the Americans, with the Canadians. I mean, they're going to need robot arms, right? We're ready. And everybody sort of comes together to build this international moon colony, moon research station. But we'll see how it all plays out. But yeah, I think your 5 launches sounds about right. All right. Those were all the questions that we had this week. So don't forget to vote for the question that you thought was the best. Just write in the Star Wars planet name and we will count them up and we will celebrate the best question next week. And don't forget to join the book club. Suggest what book I should be reading next time. All right. Thanks, everyone. And we'll see you next week. If you want to stay on top of all the important space news, join my weekly email newsletter. I send it out every Friday to more than 55,000 people. I write every word. There are no ads, and it's absolutely free. Subscribe at universetoday.com/newsletter. You can also subscribe to the Universe Today podcast. There you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at universetoday.com/podcast or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to Josh Schultz and Andrew M. Gross who support us at the Master of the Universe level. All your support means the universe to us.